Alright guys, we're going to wrap up the section we started on Friday. Kind of our review section for this unit is not going to take us that long because I think we just have 2 more examples to go over. Before we start that though, I want you to open up to page 312 from your homework. There was a typo on my end, and if you were doing some of the problems or checking the work online, the work really didn't match the directions. So on page 312 you have these 2 exponential functions at the top. Number 4 is asking you, of the 2 of them, one should be growth and one should be decay. If you actually looked at them and analyzed them for the different properties we've been discussing, they actually are both decay, so that doesn't really make sense for the directions. I had a typo. I want you to change this base of 3 over 2 to 3 over 4. That way some of the other problems check out. Okay, so it should be 3 over 4, not 3 over 2. Alright, so when you're done making that correction, let's go to page 316. So on Friday we were trying to bring all these different characteristics and graphical properties of exponential functions together. In a very broad sense, I was just going to give you a graph, a table, and an equation, and I want you to write down anything you could possibly identify. And good morning, anything for the office today? I think we're good. Thank you. Have a good day. Uh-huh. Alright, did we finish the graphing or the graph example on the left? Okay, we're on the function example. Okay, so taking a look at that equation, what are some things you can automatically determine about the exponential function or graph, different properties? Yeah?
C is -2 because it's the horizontal axis.
Alright. Oh, -2, sorry. Wonderful. Yeah. Alright, so we know the entire equation. Let's perhaps go ahead and write down some of those transformations. So we have y-axis flip, x-axis flip. Can we identify the parent function? Yeah? Alright, so we have 3 halves to the x power. So if you wanted to cross off the 3 halves and the x, everything else in that equation is some type of change. So I like the 2 flips. Are there any other changes we can identify? You want to keep going? Yeah. Down 2. Yep. Yeah. It is left 3. Good. Okay, so based off those transformations, can we write the coordinate rule? How the x and y variables are being affected? Yeah? Negative x minus 3. Yep, it's okay. Sounds good. Are we doing okay so far? Not too quick? Alright, what are some other things we can identify about what this graph might look like? Yeah? B is greater than 1. Okay, so it had the 3 halves. So it's starting as a growth if the base is bigger than 1. Can we determine what the ending graph is? If you have a growth graph initially and then you have both flips, yeah? It's going to change to decay. Good. Okay, decay because we have both reflections. Good, so it starts as growth. Ashlyn realized that. And then both flips are going to change it to decay, according to Rebecca. Yeah?
The domain is negative infinity to positive infinity, and the range is negative infinity.
Wonderful. I think there's one more thing we can write. Kind of based off this range here, is the graph located above the asymptote or below? Yeah? Below. Okay, so based off the range, notice how it's going all the way down towards negative infinity. So you're below that asymptote. How could you tell based off the equation, though? Yeah?
The A would be negative because of the negative in front of the base.
There we go. That A value, that number out front is negative. Okay, so we'll say graph is below horizontal asymptote. I like it. That's everything I basically wrote down. Are there any other characteristics or properties you guys can notice or you want to make a list of? I'm good if you're good. Okay, we got one more on the back and then that's it. So when you take a look on the next page, where is it? There it is. We have another table, but it's a little bit more directed where I give you some questions specifically to answer, not just list anything you could possibly identify. So I want you guys to try this run on your own, see how far you can get. Maybe work with the person beside you. I'll give you about, I don't know, 10 minutes or so. You might not even need that, and then we'll start to check it. Okay? Make note of the equation at the top. All right, let's check it out. Taking a look at the table and paying close attention to the function they give you, do you think this exponential graph is growth or decay? What'd you write down? Yeah? There we go. Decay because approaches horizontal asymptote to the right. Check on number 1. All right, speaking of to the right, we want to check out some end behavior here to the right and to the left. So what did you notice based off the values from the table how this graph is behaving on both sides? What's it doing on the left? What's it doing on the right? Yeah? All right, so as x approaches negative infinity, meaning towards the left, the y values are approaching positive infinity, going up forever. You may have noticed when you're going through some of the homework problems, it mentions like bounded or unbounded. Not sure if you got to any of those just yet. But this would be an example of unbounded behavior because the y values are going up forever. There's literally no bound. Okay, they're just going to keep increasing. What about on the right side? As x approaches positive infinity, yeah? Y is approaching 1, okay? This would be an example of bounded behavior. Bounded because you are trapped, okay? You are reaching some type of bound, specifically some type of asymptote. Okay, do those wordings or classifications make sense? If we were to see those words again, we would understand what they mean. Okay, what about domain and range? How far left, right, low to high? Maybe some of you tried to draw a picture of this to kind of make sense. We had decay graph. Yeah. Yep. Not negative infinity. Okay, so positive infinity to 1, or if we were to go in order 1 to infinity. Good. Okay. What about the equation of that horizontal asymptote? What height, aka y value, does it have? Y equals... Yeah, there we go. How are we doing so far? Good. All right, what about 5? What can be concluded about the value of A? So if you pay close attention, they're not asking you to find it. Okay, they just want you to tell us something about it. What can be concluded about the value of A? What do you think? Yeah.
It would be positive since y values are greater than the horizontal asymptote.
There we go. A is positive because y values are larger or higher than the horizontal asymptote. Looks good. What about 6? What can be concluded about the value of B? Again, they're not asking you to find it. They just want you to tell something about it. So is it between 0 and 1, or is it bigger than 1? Go, Rebecca.
I said it's greater than 1 because the graph is decay and there is an x-axis reflection. Sorry, not x, y-axis.
Y-axis. Good. Pay close attention to the function. There is that negative up in the power spot signifying a y-axis flip. So if you were to take a growth graph, okay, like Rebecca says, B is bigger than 1, and you were to flip this left and right, it would then change to decay, which matches the graph based off the table. Okay, so you are starting with a growth graph, B is bigger than 1. And Rebecca said because we had that y-axis flip. Good. All right, and last but not least, what can you tell me about the value of C? Good, Marie? There we go. So this one we can actually give a number value to it because we know that the number being added or subtracted on the end is related to that horizontal asymptote. There we go. How'd you do? Awesome, guys. Okay, that's basically it for today. We have a solid 20 to 25 minutes. So in preparation for the rest of the week, we're having a free response day tomorrow. If you want to get a jump start on that, you can look at those questions today. You could use the remaining time to maybe work on some homework problems because they will be due by Friday, okay, test day. I'll let you know tomorrow who your partners are for the quiz on Wednesday. All right, so the rest of the period is yours. Make sure you use it wisely.